Okay, hopefully you guys did okay on the quiz and you're understanding all the different formulas and ways to calculate areas of different polygons. And now we're going to move on to the circle portion of this chapter. So we'll do circumference and area of a circle. So it says here, perimeter is to a polygon as what is to a circle. So hopefully you're thinking to yourself that's as circumference is to a circle. So remember, perimeter is the distance around a polygon, right? So if I had some polygon like this, then the perimeter would be the distance all the way around it, adding up these side lengths. And then circumference is just like walking around the circle. That's also the outside edge. So that would be walking around the outside edge of a circle. That's your circumference. So measuring the perimeter of a polygon is easy enough. It is the sum of the lengths of the sides. Since a circle is not a polygon, it seems sensible that the perimeter of a circle is defined differently. We can calculate the perimeter of a circle, which is circumference, if we know about one special relationship that is common to all circles. So what I want you to do is when I do this little GSP demo, I want you to be writing down the circumference and the diameter of 3 different examples that I give you. So make sure you have your pencil ready. You're going to write down the 3 different circumferences and diameters. So here's the demo. So here's one for you. If I have this circle here, here's center A, and so I have the circumference of circle AB, so they're defining it based on the radius of that circle, and I have the diameter BD. So you can write down circumference is 53.76, that was letter C, and then diameter, letter D, was 17.11. Okay, now I'm going to adjust the size. Oops, I guess I have to do this one. Okay, how about this? We have circumference 31.89, and we have diameter 10.15. So write those measurements down for the second one. C is 31.89. D is 10.15, and finally, oops. How about something really big? So we have circumference of 88.71 and diameter of 28.24. Okay, so if you've recorded all of those here, then you can go ahead and calculate this ratio right here. So take the circumference and divide it by the diameter that you got for the first row. Take the circumference divided by the diameter for the second row. Take the circumference divided by the diameter for the third row. What do you notice about this ratio? So what do you notice about this ratio? So if you need more time, go ahead and pause and calculate it. But what do you know about the ratio? Well, you should have discovered the ratio to be 3.14 blah, blah, blah. And if you push the pi button on your calculator, you see these pi's everywhere over here, push the pi button on your calculator, you will get the first however many digits, 10 to 15 digits of pi. But remember, this is a number that continues forever and ever with no pattern. So this is the relationship between the circumference and the diameter of a circle. It's the ratio, right? It's the ratio of the circumference divided by the diameter of any circle. You'll get pi. So the theorem, which defines pi, if C is the circumference and D is the diameter of a circle, then there is a number pi such that the circumference equals twice, I'm not going to do that. The circumference equals pi times the diameter. So if we undo this up here, we can multiply the pi times the diameter and we'll get the circumference as a result. So you can take this numerical value, multiply it by the diameter, get this as a result. But in a circle, remember the diameter is equal to 2 radiuses, right? This is radius and this is radius. So if the diameter equals 2 radiuses, then we can also state that the circumference is twice pi times radius, or 2r, twice radius, times pi, but usually we put it in the order of 2 times pi times r. Right, so this is the same as twice r times pi. Except usually you'll see we write it like this. So that's the circumference. So here you can go ahead and read through this on your own. Okay, and then of course we can calculate here. So example number 1 says, if a circle has a diameter of 10 meters, what is the circumference? So what is the circumference? Well, the circumference is pi d, because I gave the diameter. So you would just say pi times 10. If you were going to leave your answer in terms of pi, you could just write pi, or 10 pi, sorry, but usually be rounded. Right, so that's about the same as multiplying that out and 31.42 meters, or 31.4 meters. If a circle has circumference of 16 inches, what is its radius? So this time I gave you the circumference, so 16 inches equals twice 2 pi times the radius, because I want to calculate the radius, or you could just do pi d and then divide the answer in half. So I divide each side by 2 pi. So 16 divided by 2 pi is about 2.5465, or about 2.55 inches. So the radius for this example is about 2.55 inches. Okay, so how do we get the circumference? Or how do we get pi? What's the relationship? So remember, pi is the ratio of circumference to diameter. So circumference divided by diameter equals pi, or undoing that, pi times diameter equals circumference. Right, so if we divide it by diameter here, we would see that pi is equal to circumference divided by diameter, or this is actually the formula you'll be using more often, or this one over here. Okay, moving on. So now we're going to try to figure out what the formula for area is. So it says the ancient Greeks knew of the relationship between pi and the circumference of circles. However, they couldn't decide what the relationship was between area and a dimension of a circle. So they couldn't figure out what the either diameter or radius or dimension of the circle and area. So we're going to try to discover that just like the Greeks did. And don't you just love this? I love this. All right, so how do we figure that out? Well, I can either just tell you the formula, or we can try to figure this out by working it out here with an example. So you need a piece of paper so you can do this little activity. And I will sketch it for you again to try to help explain what's happening. You might want to draw the sketches down if you're not going to actually do the activity, just so you have some reference and some visual cues of what to do. So go ahead and pause and get your paper and scissors if you want. Okay, so it says, how do we know this formula? So what is the formula? Well, go ahead and give it to you. It's just pi r squared, right? Pi times r squared. But how do we know this formula? So it says pi isn't a dimension of the circle like base or height is for polygons, so this formula seems a bit different. We're going to use a piece of grid paper. You can just use a blank piece of paper. You should have a compass and scissors, and we'll try to understand how the formula works. So first of all, use the compass to construct a circle with a radius of 10 units. So you can open it up, your compass, make it 10 of any type of unit. So my radius is equal to 10 units right here, which means my diameter is then equal to 20. It says, just for some practice, calculate the area of your circle. So my area of my circle is just going to be 10 squared times pi, or 100 pi, right? Or if you're plugging that in and you're trying to round, we would get approximately 314.16 units squared. So cut out your circle. So go ahead and cut out your circle. Fold your circle in half. So when you fold your circle in half, you're going to get a folded line. But then it's going to be a semicircle. then fold that in half so it looks like a quarter circle, and then fold that in half so you're going to get marks here, and then you keep folding it in half until you get, I don't know, 16 different circles or 16 different sections of your circle. So it looks something like that. So you fold it in half so it looks like this, and then you fold it in half so it looks like that, and then you fold it in half so it's even smaller piece like that, and then unfold your circle, and you should have fold lines everywhere like the red lines you see up here. And then it says cut on these fold lines so that you will have as many pieces that look like this at the end of it. Right, and they should all be the same size if you kept folding it in half each time. So every single one of these pieces should be the same size. Well, if I took those pieces and arranged them tip up to tip down, so here, down here, I would put a piece like this, and then on this end I put a piece here, and on this end I put a piece here. And remember, even though I'm not the best artist in the world, every single one of these pieces is the same size. So when you line them all up, the smaller you made these pieces, the more it looks like a parallelogram, right? So you have this diagonal. If I put one more piece here, one more piece here, then you would see I have this parallelogram shape. Right? So those red pieces are the pieces you cut out, the different sectors of the circle. And so then, well, what was this length right here around this edge? This is just the radius, right? This right here is the radius of the circle. Okay, well, how do we get the area of a parallelogram? Remember, the area of a parallelogram is just base times height. So here, the smaller I make these little wedges, well, your height is still the radius, because if I go up like this, right, from the tip up here, that's still the same length, which is whatever the radius was, which in our case was 10 units. So my height is 10 units. But what's my base? Well, my base is this measurement across the bottom, right, or the measurement across the top here. Well, that's all these little arcs. And we're going to have half of the circle's arcs down the bottom, and we're going to have half of the circle's arcs across the top. Well, what are those circle's arcs coming from? Those are the pieces that are making up the circumference of the circle, right? But half of them are going to go on top, and the other half is going to go on the bottom. So instead of the base being the entire circumference all the way around the circle, which is 2 pi r, it's only half of that we just said. So this just becomes pi r. Sorry, and this should be radius, which was 10 in our case. So this is how we're coming up with the formula. It's pi r for the base, because this is half the circumference along here, times the radius, which is the height, right? Because if you go from the tip here anywhere to that arc, that's the radius. So pi times r equals pi r squared, and that is how the development of the area for the circle, how the formula came about. So here's the height. We said the height was equal to the radius. We said the base is half of the circumference, which is pi r. Therefore, when we multiply them together, we get pi r times r, which is pi r squared. So if your brain is hurting and you're not sure what's happening, again, talk to me in class and I'll show you, and I'll try to explain it then. Also, really what you're going to be doing is just applying those formulas, 2 pi r for circumference, or pi d for circumference, and pi r squared for area. You're just going to be applying those to different questions, and you can practice those in class. But here's 2 that you can practice, push pause, try them, and then check my answers. Only 20 seconds left, so I'll do it quickly. Okay, 20 seconds for a super fast explanation. Number 1, set the area equal to pi r squared, divide by pi, we get r squared equals 24.98. Take the square root of both sides, you get 4.9987, which is about 5. Here, we find the area of the square was 625, the area of the circle was 796. Ask me in class if you don't get it. That's it.